Deploying your FastMCP server to AI coding assistants shouldn't require manual configuration files or guessing which dependencies to include. You'll see exactly how to install servers directly into Claude Code, Cursor, or Claude Desktop with one command, complete with dependency isolation, environment variables, and even custom Python versions. The pattern handles everything from simple scripts to complex projects with editable package requirements. Hash auto-detect server entry point looks for MCP, server or app. FastMCP install Claude Desktop server. Hi. Hash install with FastMCP. JSON configuration, auto-detects. FastMCP install Claude Desktop. Hash install with explicit FastMCP, JSON file. FastMCP install Claude Desktop myconfig, FastMCP, JSON. Hash uses specific server entry point. FastMCP install Claude Desktop server. Hi, my server. Hash with custom name and dependencies. FastMCP install Claude Desktop server. Hi, my server name, my analysis server, with pandas. Hash install in Claude Code with environment variables. FastMCP install Claude Code server. Hi env API KEY equals secret env debug equals true. Hash install in Cursor with environment variables. FastMCP install Cursor server. Hi env API KEY equals secret env debug equals true. Hash install with environment file. FastMCP install Cursor server. Hi env file env. Hash install with specific Python version. FastMCP install Claude Desktop server. Hi Python 3.11. Hash install with requirements file. FastMCP install Claude Code server. Hi with requirements txt. Hash install within a project directory. FastMCP install Cursor server. Hi project path to project. Hash generate MCP JSON configuration. FastMCP install MCP JSON server. Hi name my server with pandas. Hash copy JSON configuration to clipboard. FastMCP install MCP JSON server. Hi copy. The examples demonstrate a declarative installation pattern for MCP servers, where configuration and deployment are separated from implementation. This approach uses a unified CLI interface to handle server registration across multiple client environments, abstracting away the underlying complexity of environment setup, dependency management, and transport protocols. What makes this distinctive is its ability to bridge the gap between local development and production deployment through a single, consistent command structure. Conceptually, this works by treating server installation as a configuration-driven process rather than an imperative sequence of steps. The CLI interprets declarative inputs, whether from command line flags, configuration files, or environment variables, and generates the appropriate client-specific setup, including dependency isolation via UV, environment variable injection, and transport protocol selection. The pattern emphasizes separation of concerns. Developers focus on server logic, while the CLI handles the intricacies of client integration, ensuring reproducibility across different environments like Claude Desktop, Cursor, or custom MCP clients. This approach matters because it solves the fragmentation problem in MCP server deployment, where each client traditionally required manual configuration. By standardizing the installation workflow, it reduces boilerplate, minimizes environment-related bugs, and accelerates iteration cycles. The trade-off is a reliance on UV for dependency management, but this is justified by the need for isolated, reproducible environments, a critical requirement when deploying servers to AI clients that enforce strict sandboxing. Use this pattern when you need to deploy the same server logic across multiple MCP-compatible tools without rewriting configuration for each. Let's break it down.
Hash auto-detect server entry point looks for MCP, server or app. FastMCP install Claude Desktop server. Hi.
This installs a FastMCP server in Claude Desktop using automatic entry point detection. When no explicit entry point is specified, FastMCP scans for common server files named MCP, Pi, server, Pi, or app, Pi, eliminating manual configuration for standard projects. The pattern reduces boilerplate while maintaining explicit control when needed.
Hash install with FastMCP. JSON configuration, auto detects. FastMCP, install Claude Desktop.
This demonstrates FastMCP's auto detection pattern. When no explicit configuration is provided, it automatically searches for a FastMCP JSON file in the current directory, eliminating manual configuration overhead. The pattern enables one-command deployments while maintaining flexibility for custom setups.
Hash install with explicit FastMCP JSON file. FastMCP install Claude Desktop myconfig. FastMCP JSON.
This overrides the default configuration by explicitly specifying a custom FastMCP JSON file. Use this when you need precise control over server behavior, environment variables, or dependencies that differ from the auto-detected defaults. The pattern ensures reproducible deployments across different environments.
Hash uses specific server entry point. FastMCP install Claude Desktop server. Hi, my server.
This targets a specific function within server, Pi as the entry point. Instead of auto-detecting MCP, server, or app, it explicitly uses the myServer function, giving you precise control over which server instance gets installed. Critical when your module contains multiple server definitions or you need to bypass naming conventions.
Hash with custom name and dependencies. FastMCP install Claude Desktop server. Hi, my server name, my analysis server, with pandas.
This installs a custom-named server with explicit dependencies. The server name sets a human-readable identifier for the installed tool, while with pandas, ensures the dependency is automatically installed in the target environment. This pattern handles environment-specific requirements while maintaining clean installation commands.
Hash install in Claude Code with environment variables. FastMCP install Claude Code server. Hi env API KEY equals secret env debug equals true.
This installs the server into Claude Code while injecting environment variables directly. The env flag handles runtime configuration without modifying source code, ensuring sensitive values like API keys stay out of version control. Critical for production deployments, where configuration must remain environment-specific.
Hash install in cursor with environment variables. FastMCP install cursor server. Hi env API KEY equals secret env debug equals true.
This installs the server into cursor IDE with environment variables injected at runtime. The env flags pass sensitive configuration like API keys directly to the server process, eliminating hard-coded secrets while ensuring they're available during execution. This pattern mirrors production deployment, where environment variables handle configuration.
Hash install with environment file. FastMCP install cursor server. Hi env file env.
This loads environment variables from an env file during installation, eliminating manual configuration. Critical for production deployments, where secrets and settings must be version controlled separately. The env file flag handles bulk environment setup in one command.
Hash install with specific Python version. FastMCP install Claude Desktop server. Hi Python 3.11.
This enforces a specific Python version for the installation, eliminating version conflicts that could break dependencies. Critical when your tool requires features from a particular Python release or when the target environment has strict version requirements.
Hash install with requirements file. FastMCP install Claude Code server. Hi with requirements txt.
This installs the server while explicitly specifying a requirements txt file. The with requirements flag ensures all dependencies are installed in one step, eliminating manual pip installs and preventing version conflicts. This pattern is essential for reproducible deployments where you need exact dependency control.
Hash install within a project directory. FastMCP install cursor server. Hi project path to project.
This forces installation within a specific project directory, ensuring all dependencies and configurations are contained in one place. The project flag eliminates environment conflicts by isolating the installation, critical when working with multiple code bases or monorepos.
Hash generate MCP JSON configuration. FastMCP install MCP JSON server. Hi name my server with pandas.
This generates a standalone MCP JSON configuration file instead of installing directly. Useful for version control, team sharing, or manual inspection before deployment, it captures all tool definitions, dependencies, and metadata in a portable format. The name parameter sets the human-readable server name, while with explicitly declares dependencies like pandas, ensuring they're included in the generated configuration. This pattern enables reproducible deployments across environments.
Hash copy JSON configuration to clipboard. FastMCP install MCP JSON server. Hi copy.
This generates MCP JSON configuration and copies it directly to the clipboard, eliminating manual file handling. Useful for quick sharing or deployment without file system access. The pattern mirrors Unix-style tool, chaining where output streams to the next tool. FastMCP installation patterns. The FastMCP install command bridges local development and MCP client isolation, handling everything from dependency resolution to environment configuration across multiple clients. Environment variables must be explicitly declared. They never inherit from your shell or local system. A single configuration file can deploy the same server to Claude Desktop, Cursor, or as raw MCP JSON.
The server that runs everywhere belongs nowhere.